Welcome to Ask and Learn.
In this exercise, we're going to be dealing with an inclined plane problem. So before diving into the exercise, let's first review briefly how we should treat inclined planes. So consider that we have a block in an incline as shown in the picture. So this is the incline, and this is the block. The block has a mass m, and the incline makes an angle of theta with the horizontal. Consider now the block as a free body, so we must draw the forces on the block. That is, we must draw the free body diagram. There's a force that acts downwards, that's just the gravity's force, that's equal to mg. There's a normal force that the surface exerts on the block that points perpendicularly to the block, perpendicularly to the surface. And there's also a friction force that points opposite to the direction of motion of the block. This is the friction force that I'm going to call Ff. And I'm going to choose a system of coordinates such that the x-axis points along the incline but downwards, and the y-axis points perpendicularly to the incline upwards. So let's write the sum of the forces in the y component. We have the normal force minus the gravity component along the y direction, which is mg cosine theta. And since the block is not moving, this is equal to 0, which means that the normal is equal to mg cosine theta. And actually, when I said that the block is not moving, is that it's not moving in the y direction. Now in the x direction, let's assume that the block is moving with an acceleration a downwards. So the sum of the forces is the component of the gravitational force along the x direction, which is mg sine theta, minus the friction force, and this is equal to the mass times the acceleration. Now the friction force is equal to the coefficient of kinetic friction, mu k, times the normal force, so it's mg cosine theta, and this is equal to ma. Okay, so in the end we have that g times sine theta minus mu k times cosine theta is equal to the acceleration. And now we have every information we need in order to solve the exercise. So in the exercise, we have a block that has a mass of 12 kilograms that lies on a surface that has a coefficient of kinetic friction of 0.3 and an initial speed v0 of 2.5 meters per second. And the incline makes an angle of 30 degrees with the horizontal. Our goal is to find what is the final speed of the block after it slides down the incline that has a length of 3 meters. Okay, so first, I'm going to calculate the acceleration of the block with the information we have. Then, with the acceleration, I'm going to use Torricelli's formula that tells us that the speed squared is equal to the initial speed squared plus 2 times the acceleration times the distance traveled. And with this, I'm going to be able to find the speed. So let's start first by finding the acceleration. As I showed before, the acceleration is equal to the gravitational constant g times sine of theta minus mu k cosine of theta. g is 9.8 meters per second squared. Then we have the sine of the angle 30 minus 0.3, this is the coefficient of kinetic friction, times cosine of 30. Okay? So basically, we can insert this into the equation for the speed. So we have the speed is the square root of v0 squared plus 2 times g sine of theta minus mu k cosine of theta, which is the acceleration, times delta x. So this is the square root of 2.5 meters per second squared. That's the initial speed, plus 2 times 9.8 meters per second squared times sine of 30 minus 0.3 times cosine of 30 times the length, which is 3 meters. So V is equal to 4.51 meters per second, which concludes our exercise.